Some examples of XR learning experiences at the University of Toronto and beyond. Professor Heather Thompson from the Bloomberg Faculty of Nursing led the creation of 360 videos for nursing students. The videos are recorded from the perspective of a patient receiving updates from a doctor and an intervention from a nurse. The rationale is that this could enable greater understanding of a patient's perspective and foster empathy in patient care. The videos can be viewed through an immersive stereoscopic viewer, or they can be viewed online on a monitor, such as you see here in the video frame. Now an example from chemistry with augmented reality. Professor Shadi Dalili and her team from UTSC created 3D molecule visualizations as an augmented reality app. Students can use this app to help them understand molecular structures and transformations. VR in a Genomics methodologies course. Instead of a time-consuming and expensive-to-run real-life lab, Professors Joanna Carroll and Martina Steiner in molecular genetics assigned a virtual lab to their students. This was commercially available VR content. It could be viewed in an all-in-one wireless head-mounted display or online on a monitor, which is sometimes called WebVR. The modules were very interactive. Learners performed the lab experiment activities. And finally, one example from the humanities. This one comes from Vanderbilt University. Lynn Ramey, a professor of French and medieval literature and culture, had students code a gamified virtual environment that recreated medieval Cyprus and featured the storytelling traditions of that era. This is still in progress, but it's created by a multidisciplinary team of students, and it is for course credit. So this is being created over several semesters. As you may be concluding, there's a continuum of access points for XR. So there's off-the-shelf VR and AR experiences commercially available, but you may have little ability to customize those. Then there are authoring apps that make it easy for educators or even students to create an AR app or a 360 video. If you want something that is totally customized and suits your particular learning outcomes, you may consider creating from scratch. But of course, this takes a little bit of time and specialized equipment. So some of the challenges with VR. The equipment is still expensive, especially for the higher-end VR headsets, and in many cases the computers that run them or that are needed to create VR experiences. If the content you need doesn't exist, creating it yourself will take time and may require significant funding. Unfortunately, virtual reality is not fully accessible to all, because it's primarily audio-visual. Anyone with perceptual disabilities won't get the full benefits of a VR experience. You could incorporate closed captions or sign language interpretation into a VR experience, but making up for the visual aspect would be a little more challenging. However, there are people working on this problem. There's an interesting project from a museum in Prague where they mapped out the dimensions of famous sculptures, and visitors with visual impairments put on specialized haptic feedback gloves, and they can actually feel the statues. They can touch the statues and feel all the contours. So it's coming at a virtual experience through different senses, not necessarily visual or audio. This concludes our brief overview of XR technologies for learning. If you have any questions or want to discuss your ideas, please visit the University of Toronto's AR/VR network page at this URL, onlinelearning.utoronto.ca/AR-VR network.